The National Electrical Code, specifically the 2023 edition, addresses the placement of overcurrent protection devices. It's true that these devices, which include circuit breakers and fuses, are generally not permitted in locations such as attics, closed closets, and bathrooms. However, there is an exception. According to Article 240.24c of the NEC titled Locations Not Permitted, overcurrent protection devices are prohibited in those locations unless enclosed in a suitable enclosure. This means that if the subpanel containing the overcurrent protection is housed within an enclosure designed and approved for the environment, installation may be permissible. It is important to note FBN Note 1, which directs the reader to Section 110.11 for guidance on selecting appropriate enclosures, particularly when dealing with closed closets. Section 110.11 deals with environmental deterioration. Unless identified for use in the operating environment, conductors and equipment shall be protected against the following: firstly, physical damage; secondly, the effects of heat or cold; thirdly, corrosive vapors; fourthly, excessive humidity; and fifthly, contamination. This section of the NEC is crucial for ensuring the longevity and safety of electrical installations in potentially harsh environments. The attic environment, for example, can be subject to extreme temperature fluctuations and dust accumulation, requiring specific types of enclosures to protect the electrical components within. An enclosure for a subpanel in an attic needs to meet several requirements. Firstly, it must be rated for the environmental conditions of the attic, considering temperature, humidity, and dust. Secondly, it needs to provide adequate protection against physical damage. Thirdly, it must be sized appropriately for the subpanel and any associated wiring. The selection of the correct enclosure is essential for compliance with the NEC and ensuring the safety of the electrical installation. Furthermore, the NFPA 70E Standard for Electrical Safety in the Workplace provides additional safety guidelines related to electrical work. Section 130.7 addresses electrical equipment and emphasizes the importance of energizing equipment before working on it. Subsection 130.7c10 specifically mentions disconnecting equipment from all power sources to minimize the risk of electrical shock or arc flash. This standard reinforces the need for qualified personnel to perform electrical work and to use appropriate personal protective equipment and insulated tools. Applying this to the scenario, installing a subpanel in a residential attic space requires careful consideration of both the NEC and NFPA 70E standards. While the NEC allows for the installation of overcurrent protection devices in attics if enclosed in a suitable enclosure, it is crucial to select an enclosure that meets the specific environmental conditions of the attic. The installation should only be performed by qualified electricians who are familiar with these codes and standards and who can ensure that the installation is safe and compliant. Before beginning any work, the electrician should verify that the circuit is energized and follow all applicable safety procedures, including the use of personal protective equipment. If the attic is difficult to access or has other safety hazards, the electrician may need to take additional precautions such as using scaffolding or fall protection equipment. The choice of enclosure for the subpanel also depends on the specific type of overcurrent protection devices being used. Circuit breakers and fuses have different requirements for enclosure size and ventilation. It is also important to consider the potential for future expansion when selecting an enclosure. Choose an enclosure that is large enough to accommodate additional circuits if needed. In summary, while it may be permissible to install a subpanel with overcurrent protection devices in a residential attic, it is essential to do so in compliance with the NEC and NFPA 70E standards. This includes selecting a suitable enclosure that is rated for the attic environment, ensuring that the installation is performed by a qualified electrician, and following all applicable safety procedures. Failing to comply with these standards could result in electrical hazards, property damage, or even injury. When planning an electrical installation in an attic space, several factors must be considered to ensure safety and compliance with the National Electrical Code. Let's delve deeper into these considerations. Firstly, environmental factors. Secondly, enclosure selection. Thirdly, accessibility and working space. Fourthly, load calculations. Fifthly, wiring methods. Sixthly, grounding and bonding. Seventhly, overcurrent protection. Eighthly, safety practices. Ninthly, inspection and permitting. And tenthly, future expansion. Firstly, environmental factors are paramount. Attics are often subject to extreme temperature fluctuations, high humidity levels, and the accumulation of dust and debris. These conditions can significantly impact the performance and lifespan of electrical equipment. Therefore, all equipment installed in an attic must be rated for these environmental conditions. This includes selecting enclosures, wiring, and overcurrent protection devices that are designed to withstand the temperature extremes, humidity, and dust prevalent in attic spaces. Secondly, enclosure selection is crucial. As previously mentioned, the NEC requires that overcurrent protection devices in attics be enclosed in a suitable enclosure. This enclosure must provide adequate protection against physical damage, dust, moisture, and temperature extremes. The type of enclosure selected will depend on the specific environmental conditions of the attic. For example, in a damp or humid attic, an NEC 3R or 4 rated enclosure may be necessary to protect against moisture ingress. In a dusty attic, an NEC 12 enclosure may be required to prevent dust from entering the enclosure and affecting the electrical components. Thirdly, accessibility and working space are important considerations. The NEC requires that sufficient access and working space be provided around electrical equipment to allow for safe and effective maintenance and repairs. This means that the subpanel must be installed in a location that is easily accessible and provides adequate working space for an electrician to perform tasks such as inspecting, testing, and replacing components. In attics with limited headroom or difficult access, this can be a challenge. However, it is essential to comply with the NEC requirements for accessibility and working space to ensure the safety of electricians and prevent future problems. Fourthly, load calculations are essential to determine the appropriate size of the subpanel and the overcurrent protection devices. The load calculation must take into account all of the electrical loads that will be served by the subpanel, including lighting, appliances, and other equipment. The subpanel and overcurrent protection devices must be sized to handle the total load without overloading the circuit. Overloading a circuit can lead to overheating, which can cause fires. It is important to consult with a qualified electrician to perform an accurate load calculation and ensure that the subpanel and overcurrent protection devices are properly sized. Fifthly, wiring methods must comply with the NEC requirements for the specific type of wiring being used. The NEC specifies the types of wiring methods that are permitted in different locations and under different conditions. In attics, it is common to use non-metallic sheet cable, also known as Romex, or conduit. The wiring method selected must be appropriate for the environmental conditions of the attic and must be installed in accordance with the NEC requirements. This includes properly supporting and securing the wiring, protecting it from physical damage, and ensuring that it is not exposed to excessive heat. Sixthly, grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to return to the source, which helps to prevent electrical shock. Bonding connects all of the metal parts of the electrical system together to create a low impedance path for fault current. The NEC specifies the requirements for grounding and bonding in different situations. In attics, it is important to ensure that the subpanel is properly grounded and bonded to the building's grounding system. This will help to protect against electrical shock and prevent damage to equipment. Seventhly, overcurrent protection is the primary means of protecting electrical circuits from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The NEC specifies the requirements for overcurrent protection in different situations. In attics, it is important to ensure that the subpanel is equipped with overcurrent protection devices that are properly sized and rated for the circuits they protect. The overcurrent protection devices must be installed in a readily accessible location and must be protected from physical damage. Eighthly, safety practices are paramount when working with electricity. The electrical work can be dangerous, and it is important to take all necessary precautions to prevent electrical shock and other injuries. This includes wearing appropriate personal protective equipment such as safety glasses and gloves, and using insulated tools. It is also important to de-energize circuits before working on them and to verify that they are de-energized using a voltage tester. Only qualified electricians should perform electrical work in attics. Ninthly, inspection and permitting are essential for ensuring that electrical installations comply with the NEC and local codes. Most jurisdictions require that electrical work be inspected by a qualified inspector to ensure that it meets the applicable codes. It is important to obtain the necessary permits before beginning any electrical work in an attic. The inspector will verify that the installation is safe and compliant with the NEC and local codes. Tenthly, future expansion should be considered when planning an electrical installation in an attic. It is often easier and more cost-effective to install a larger subpanel than is currently needed to accommodate future electrical loads. This can save time and money in the long run if additional circuits are needed in the future. It is also important to consider the potential for future changes in the use of the attic. For example, if the attic is likely to be converted into living space in the future, it is important to install adequate wiring and overcurrent protection to support the additional electrical loads. In conclusion, installing a subpanel in an attic requires careful planning and execution to ensure safety and compliance with the National Electrical Code. By considering the environmental factors, selecting the appropriate enclosure, providing adequate accessibility and working space, performing accurate load calculations, using proper wiring methods, ensuring proper grounding and bonding, providing adequate overcurrent protection, following safe work practices, obtaining the necessary permits and inspections, and considering future expansion, it is possible to safely and effectively install a subpanel in an attic. It is important to consult with a qualified electrician to ensure that the installation is done correctly and in accordance with all applicable codes and standards.